In this video, we are going to solve the following problem. We want to find the integral part of the following expression. So we have 1 plus 1 divided by root 2, and we continue the sum till we get 1 divided by root n. And we want to find the integral part of this expression for n equal to 100. So for example, let me just call this Sn. And so we have, for example, S1 is 1, S2 is 1 plus divided by root 2, S3 is 1 plus 1 divided by root 2 plus 1 divided by root 3. And the integral part of a number, so integral part of a number, which is denoted in this way, we have brackets and we have x, where x is a real number. And this is like the closest integer less than x. So for example, we have the integral part of 1.2 is 1, the integral part of 2.4 is 2, and the integral part of minus 1.3 is minus 2. So it needs to be less than this value, and it needs to be the closest number we can get. So for example, here I have 0, 1, 2, 3, and minus 1, minus 2, and then I get this minus 1.3. This is the closest number to closest integer to minus 1.3, which is less than this value, right? And the same for here. We have 1.2 for the in this direction. If we go to the left, the first integer we get is 1. So the integral part of 1.2 is 1, and the integral part of minus 1.3 is minus 2. And if x here is already an integer, the integral part is itself. So integral part of 2 is 2, integral part of minus 2 is 2, integral part of minus 1 is minus 1, etc. Okay, so now here I have this expression and I want to find the integral part of this expression. So obviously I don't want to actually compute the whole expression because it may not be possible. I just want to find the integral part of it. Basically want to find Sn larger than k, less than k plus 1, then the integral part would be k, right? I actually want to find this k value for n equal to 100. So let's see what we can do. So let me write Sn, again here 1 plus 2 divided by right n. Then I'm going to look at 1 divided by 2 times Sn, and value I would get would be, let me write it in the form of a sum here, sum of 1 divided by k, k from 1 to n, correct? And this is actually 1 divided by 2 times Sn. Now I'm going to look at this expression here that I have 1 over 2 times root k. And if you look at it, this is larger than k minus 1 and less than root k plus 1 minus root k. So why this is true? Let's try to prove it. Claim following holds for all k larger than. So proof, we have what exactly we want to show. Bring it here and bring it down. So let's start with the left hand side. We have minus root k minus root k minus 1 less than root of less than half of 1 over root k, right? This is true if and only if 1 over root k minus 1 is less than 2 root k, right? And this is true if and only if root k plus root k minus 1 divided by root k plus root k minus 1 times root k minus root k minus 1 is less than or equal to 2 root k, right? I just multiplied both the denominator and numerator with this value. And this is true if and only if root k plus root k minus 1 less than 2 root k. And this is true if and only if root k minus 1 less than root k. Correct? So this is a proof for the left-hand side, and the proof of the right-hand side follows similarly. So right-hand side follows similarly. Okay, so we have this bond here, which I'm going to take to the next page, paste it here. All right. And so what does this mean? Let me write root 2 minus 1 divided by root 2. And I'm going to put k equal to 1. And I'm going to get minus 1. And then I'm having root n minus 1 divided by 2 root n. This is less than 1 minus n. And if I sum the middle column here, I would get 1 over 2 times Sn. And if I sum the left column, this part, I would get root n minus. Okay, I made a mistake here. This is root 1 minus 0, which is basically 1. And the right hand side is correct. So I would get root n minus 0. And on the right hand side, I would have root n minus 1 minus 1. So this is the conclusion, right? So if I sum all of this, I would get this expression. Let me color it red. And I'm going to resize it. So I have this expression, and therefore 2 root n is less than Sn, less than 2 root n minus 1, less than 2 times root n plus 1 minus 1, right? And then from here, just plug in the value n equal to 100. I have 20 is less than S 100, less than 2 times root 101 minus 1. Okay, so now I just need to show that this is less than 21. Once I show it that the right hand side is less than 21, I have proved that the integral part of S100 is 20. And to actually show this, we have root 101 minus 1 is less than 21 divided by 2, which is 10.5. and then root 101 needs to be less than 11.5, and then 101 should be less than 11.5 to the power 2, right? But 11.5 to the power 2 is larger than 11 to the power 2, which is 121, and this is definitely larger than 101. So we basically show the answer is 20.